Hello, good afternoon and welcome. This is Elena Santalla speaking. Today we are going to see the first webinar about efficient street lighting, starting with some specific concepts, and next Thursday we will talk about energy efficiency measures and how to calculate energy savings. This webinar is going to have 4 main points. First of all, we are going to see a brief introduction about the relevance of street lighting within public budgets. Second, we are going to explain different lighting technologies and the comparison between LED with other light sources. Third, we are going to describe the methodology to design an efficient street lighting. And finally, we are going to review the current legislation available related to efficient street lighting. Street lighting is an important budget item within public budgets. It represents 50% of energy costs and 50% of maintenance costs. So it's a key item to try to minimize. According to a national study from the Spanish Institute for Energy Diversification and Saving, let's see some figures about the Spanish street lighting. There are 8 million light points installed with a consumption of 5,300 gigawatts hour, and that represents a cost of more than 500 million euros a year. Due to the importance of the street lighting in public budgets, energy efficiency actions for street lighting are promoted by the European Union since 2012 with the Energy Efficiency Directive. Furthermore, street lighting measures are included in national energy efficiency action plans as key points to improve public sector. Energy performance contracting can be a very good solution to make street lighting refurbishment happen due to its high energy and cost savings potential. Moreover, the LED technology offers high energy savings with comparatively short paybacks. According to the study from the Spanish Institute for Energy Diversification and Saving, there are more than 150 municipalities in Spain performing street lighting refurbishment projects with an energy service company, and the average investment per light point is about 631 euros. The good news is there is a 50 to 70% of potential energy savings in street lighting, and that gives us a good range of improvement in this kind of facilities. The key point is trying to reduce the power installed by replacing existing lamps for others more efficient, I mean replacing mercury vapor by LED, replacing existing luminaires for others with higher efficiency, for example, avoiding globes without reflector, and introducing control and regulation systems to ensure just the light needed every moment. After this brief introduction, we are going to talk now about lighting technologies, basically luminaires, lamps, and control systems. In the first picture, you can see a luminaire. It is the mechanism that distributes, filters, or transforms the light emitted by the lamp. It protects the lamp, which is quite important when talking about outdoor lighting, and prevents lamp's glare. The second picture is a lamp, which is the main source of artificial light. Some kind of lamps require an electrical equipment for igniting and maintaining the luminous intensity. This auxiliary equipment is also called ballast, which is the third picture. And finally, a control system is needed to switch on and off the light. It is also used to regulate the luminous flux of the lamps. And this is a very important thing when talking about street lighting, because the light needed at 10 p.m. is not the same as at 5 a.m. So we can vary the luminous flux to reduce the electricity consumption. So let's see different types of luminaires. Outdoor luminaires can be classified according to several criteria. Let's see an example from the Spanish Institute for Energy Diversification and Saving, based on the specific use of the luminaire. I mean if it is a functional lighting, ambient lighting, or ornamental lighting. The 3 first pictures are luminaires characteristic of roads, that is, functional lighting. These luminaires are mounted in high poles and allows for an elevated spacing between them. The difference between type 1, 2, or 3 is the type of closure. Type 1 is the one with a flat closure, which is the most efficient one. Type 2 is the one with a curved closure that allows a large opening angle presenting higher light pollution. And type 3 is the one without closure, which of course is the most inefficient one. The next 3 pictures are luminaires used in pedestrian areas, which is ambient lighting. These luminaires are mounted in lower poles with a smaller spacing between them. They can be classified as artistic or as a globe. And in the end, we can see a projector, which is the typical ornamental luminaire used to illuminate a monument or the front of a building. So, what do we have to consider when choosing a luminaire? First, we have to consider the light we need. I mean the quantity and quality of the light required. Second, the photometry and also the light pollution, which is a very important parameter to take into account when talking about street lighting. By photometry, I mean the efficiency of the luminaire or lighting output ratio, which is the rate between lamp light and luminaire light. Third, we have to consider the protection of the luminaire since it's an outdoor use application. And finally, the cost of the luminaire. Let me explain you now all these parameters. Depending on the use of the street lighting, there is a quantity and quality of light required. For example, if we are designing the lighting for a highway, we need 15 luxes instead of 5 luxes required to illuminate a park. So depending on the design of the optical compartment of the luminaire, you can get more or less light. For example, an artistic luminaire with a lamp mounted vertically gives a lot of light above the horizontal line. So in a highway with high luxes requirements, maybe it is better to install an LED bulb on top of the luminaire to focus the light to the ground. Anyways, we will talk more about this later when talking about lamps. We define the luminaire efficiency as the flux emitted by the luminaire with respect to the flux emitted by the lamp. We also call this the lighting output ratio, and the closer this ratio is to 1, the better. In street lighting, this ratio usually comes from 30 to 80%. A road luminaire type 1 presents an 80% lighting output ratio, while a globe without reflector presents a 35% lighting output ratio. But it is not only important the efficiency of the luminaire. When talking about street lighting, we cannot forget the light pollution. There is a parameter called hemispheric upper flux, which is defined as the light emitted directly above the horizontal line. This parameter depends directly on the type of luminaire used. This parameter is limited in some areas with special requirements, where the light pollution is restricted because there are some wildlife species or astronomical observatories in the surroundings. Let's see an example. Globes without reflector present an hemispheric upper flux of 50%. That means that half of the light emitted by the lamp goes above the horizontal line. However, artistic luminaires present lower hemispheric upper flux from 5 to 25%. The protection of the luminaire is also important when talking about equipment working outdoors. The IT grade stands for the protection against the entry of solid, dust or water. The higher this grade is, the better. Typical values for street lighting luminaires are IP65 or IP66. Normally, this parameter is not under IP65. The IT grade stands for the impact protection. The higher this grade is, the better. Typical values for street lighting luminaires are IK7 or 8. We cannot forget the economic side of the project. The design of a street lighting has to be technically possible, but also economically. So we have to consider the cost of the luminaire, its installation, and its running and maintenance cost. We have to reach a compromise between the optimal solution and the profitability of the whole project. For example, sometimes we can consider to maintain some luminaires more or less efficient instead of replacing all of them for LED technology, just looking for the profitability of the project. Now, let's see different types of lamps. The lamp is the equipment that converts electricity in light. We find several ways of getting this light. The most common are incandescents, where we get the light when a body reaches certain temperature, but these kind of lamps are no longer used in street lighting. Gas discharge, I mean fluorescence, where we get the light when an arc between electrodes stimulates a gas. These kind of lamps are very common in street lighting. They can be mercury vapor lamps, high-pressure sodium vapor lamps, and metal halide lamps. And finally, solid-state lighting. I mean LED technology, the most efficient one nowadays. LED stands for light-emitting diode, and it is a diode composed of several layers of semiconductor material that emits light when it is correctly polarized through the path of electric current. The diode and its electrical circuit are encapsulated in a plastic package, and it is also typically used in traffic lights, decorative lighting, and signs. In these pictures, we can see the most common lamps used in street lighting. In the left side of the slide, we can see mercury vapor, high and low pressure sodium, metal halide, which are typical discharge lamps. And in the right side of the slide, we can see different LED luminaires, which has been the revolution in the latest years. The most important thing about LED luminaires is that we have to consider the heat dissipation. LEDs don't radiate energy, so we have to dissipate the heat by other ways. Elsewhere, the temperature becomes too high and the lamp performance is lower. So what do we have to consider when choosing a lamp? First, we have to consider the light we need. I mean the quantity and quality of the light required. Second, the efficiency of the lamp measured in lumens per watt. Third, we have to consider the lifetime of the lamp. And finally, the cost of the lamp. Let's see all these parameters. If we talk about the quantity of light, it means the power of the lamp measured in lumens, not in watts. Be careful about this. There is also important the amount of light that reaches the surface, measured in luxes, which is lumen per square meter, and the amount of light that the lighted surface gives back, which is called luminance. The light needed depends on the application. We will see some reference values later on. On the other hand, if we talk about the quality of the light, it means our capacity of seeing different colors. In the case of street lighting, this is not a big deal. So we are talking about color rendering index around 70 or less. For example, LED presents an 80 color rendering index, while a high pressure sodium vapor presents 60. We can also think about the correlated temperature color, which are around 3000 Kelvin, which is orange color, to more than 4000 Kelvin, which is white color. In the picture, we can see the same hand lighted with two different lamps. These pictures are from a colleague working on a project in La Palma Island, which is one of the Canary Islands. This is a special project because there is an astronomical observatory in the island, and the light pollution requirements are higher than in other areas. The left picture corresponds to a low-pressure sodium lamp, and we can see the nails as black color. However, the right picture corresponds to a PC amber lamp, which is a special LED lamp designed with orange color, and we can see the nails as red. This is really amazing, and I assure you it is the same hand in the same moment. We were running a pilot with the PC amber lamp, and aside there was a low-pressure sodium lamp. So we take both pictures at the same time. The lamp efficiency is the relationship between the emitted light and the electrical energy consumed by the lamp. It is measured in lumens per watt, and the higher this ratio is, the better. This ratio usually varies from 100 to 160 lumens per watt when talking about street lighting. Another important parameter to take into account when talking about street lighting is the lifetime of the lamps. The life of a lamp takes into account the average life and the flux depreciation of the lamp. For example, LED has a life of 30,000 hours instead of a high-pressure sodium vapor that has a life of 10,000 hours. That is one of the key points of using LED technology in street lighting. In addition to their high efficiency, they present a larger lifetime, so the spacing between replacements is also larger with the subsequent maintenance cost saving. This becomes really important in some applications where the maintenance works are difficult, such as tunnels or high luminaires in highways. The number of replacements is also related with the economic side of the project. If a lamp is not very expensive but has a short life and a high cost of installation, the replacement cost will be expensive. So we have to consider not only the cost of the lamp, but also its installation and its running and maintenance costs. As I said before, we have to reach a compromise between the optimal solution and the profitability of the whole project. Also, we have already talked about this. Let's compare now LED with other light sources. In the chart, we can see that the efficiency of LED is similar to other light sources usually used in street lighting, like high-pressure sodium lamps or metal halide lamps. Let me explain you the following table. There are two columns for efficiency. The first one is the efficiency of the lamp measured in the laboratory. The second one is the efficiency of the lamp mounted in an actual luminaire. You can see that this second efficiency is always lower than the first one because of the different working conditions. The actual luminaire can be working at 13 Celsius degrees, while the efficiency in the lamp's datasheet is being measured at 20 Celsius degrees. The lifetime values are for the system, I mean the lamp mounted in the luminaire, and the color rendering index is for the lamp. In this table, we can see that LED presents the highest lifetime with more than 50,000 hours with a quite good efficiency and color rendering index. As you already know, in the latest years, LED technology has made a revolution in lighting world. It is expected that LED would reach the 60% of lighting systems in 2020. But it is essential to know the advantages and disadvantages of this new technology depending on the application you want to use it. And it is also very important to consider the warranties given by the LED supplier, as it is a quite new technology and there are some suppliers with uncertain prestige. And be careful because it's important to check the warranty of all the components of the luminaire, because sometimes the supplier warranties the lamp but not the auxiliary equipment, for example the driver. Finally, let's talk about control systems. The control system is needed to switch on and off the light and also to regulate the luminous flux of the lamps. The light needed at 10 p.m. is not the same as at 4 a.m. So we can vary the luminous flux to ensure just the light needed every moment and therefore reduce the electricity consumption. There are several control systems. The most common are here in the picture. We can have clocks where you schedule the hour of ignition and shutdown of the street lighting, and if it's an astronomical one, the schedule is based on the hours of darkness between sunrise and nightfall, so it's more efficient than a regular clock. Another system is the photocell that turns the light on when the light level is below a certain figure. This system is quite common in street lighting but has to be cleaned to work properly, so the maintenance cost is higher than in other systems. Presence detection is not very common in street lighting, especially in roads because of traffic safety issues. And finally, remote management. It could be centralized in control centers or inside in every light point. This is the most efficient control system since it enables not only the ignition and shutdown of the lights like the other ones, but also the regulation of the luminous flux of the lamps. Sometimes we can use the ballast, which is an auxiliary equipment needed in discharge lamps for igniting, as a regulation system. There are electronic ballast with several steps of regulation scheduled for default. To sum up, let's see this table with the main characteristics of different types of lamps. If we focus on the second column, which is efficiency, we can see that high-pressure sodium, metal halide, and LED are the best. In most street lighting, we can find this kind of lamps. All of them present different ranges of power, color rendering index, and correlated color temperature, and depending on the application, we can choose one or another. In most cases, there are some waste management components to consider, and an auxiliary equipment is required. If we focus on lifetime, LED is the one with higher values, almost doubling other technologies' lifetime. If we focus on the last column, we can see that LED is the lamp with the widest range of regulation, and this is a key point of the efficiency of this technology. Now that we have explained the different lighting technologies available for street lighting, let's see the methodology to design an efficient street lighting. If we want to design an efficient street lighting, we have to consider some variables. First, we have to consider the lighting level needed. I mean, depending on the type of road and current regulations, a lighting level must be ensured. Second, we have to choose the color temperature. For example, blue light is more energetic and it can cause interference on astronomical observation and animal activities. Third, we have to consider to choose the control system. If we can afford a remote management system, it is better than a photocell or an astronomical clock. We have also to consider if there is any special requirement related to light pollution. Usually, there are local regulations about this. And finally, the cost of the whole project, considering energy cost, technology cost. For example, high-pressure sodium is cheaper than LED, and operation and maintenance costs, including replacement costs. As I said before, we have to reach a compromise between the optimal solution and the profitability of the whole project. In this table, we can see the lighting levels recommended by the Illuminating Engineering Society of North America. For highways, 15 luxes are needed, while in roadways, 5 luxes is enough. There should be national regulations in every country, but we can take these levels as a guideline. And how can we ensure that our solution reaches these lighting levels required? There are some software that simulate the solution and calculate its lighting level. The inputs for this kind of software are the geometry of the road, I mean how wide it is, and the composition, if there are 2 lanes and 2 sidewalks or even a cycle path, the distribution of the luminaires, I mean if they are all in the same side or distributed in both sides, and of course the type of luminaire, how tall it is, and the type of lamp. With all these inputs, the software calculates the lighting level achieved with the solution proposed, so you can check if it fits the requirements or not. Now, let me show you some figures from an actual case study. Let's suppose that we have 18 road type 2 luminaires with 125 watts mercury vapor lamps with no control and regulation system. Assuming they work 4,320 hours per year, it means a consumption of almost 10 megawatt hour per year. As these luminaires are installed in a roadway, the lighting level recommended is 5 luxes. Okay, with all the data, the proposed solution is to install road type LED luminaires with 70 watts LED lamps and a remote control system that ensures a 30% energy saving due to the reduction of hours of operation. With the new solution, the consumption will be almost 6 megawatt hour per year. That means a 61% potential saving because of the reduction of power installed, hours of operation, and number of replacements. To conclude, we are going to review the current legislation available related to efficient street lighting. Eco-design requirements for some kind of lamps, related equipment, and luminaires are promoted by European Union since 2009 with different regulations. The directive of 2009 includes the phasing out of incandescent lamps by 2010, high-pressure mercury lamps by 2015, and medium-efficient metal halide lamps by 2017. Later, in 2010, a new directive required the labeling of all lamps and luminaires on the market with an energy efficiency class coming from A++ to E, similar to the one used in appliances, for example, in our refrigerator. I would like to call your attention to this voluntary standard, the EN 13201 of 2003, that defines, according to photometric requirements, lighting classes of road lighting. It also includes a methodology for the selection of lighting classes, calculation of performance, and how to measure lighting performance. It is a voluntary standard, which is a great guideline to be used to design an efficient street lighting. To sum up and finish the presentation, let me show you a case study from the Spanish legislation. Nowadays, there are two main regulations about street lighting here in Spain. One is the low voltage electrotechnical regulation, which is a mandatory regulation that describes the assembly, operation and maintenance of every low voltage installation. And there is also an energy efficiency in street lighting regulation, which is mandatory for every new lighting facilities or the modification of an existing one. There are some exclusions for special uses like traffic lights, military and maritime signals, airports or mining. But in general, it's mandatory for every public or private lighting facilities with an installed power of more than 1 kilowatt. This regulation describes the requirements of the street lighting in terms of energy efficiency. In detail, it describes lighting levels recommended, energy qualification, which is quite similar to the energy efficiency class in lamps labels, energy efficiency minimum requirements of the facilities, methodology to measure lighting levels, etc. Let me encourage you to take the opportunity of have a look to this regulation. I'm afraid it's only available in Spanish, but there are some tables with interesting parameters that can be helpful as a guideline. And that's all. I have finished my presentation. Thank you for your attention, and if you have any questions, I will be pleased to answer them.